Hi, this is Mike Edwards, the instructor for the Functional Bioinformatics class that I'm teaching for the Department of Bioengineering. In this video, what I'm going to do is show you how to download the gene list that we made last class period into Nginity. And I'd like you to do this before class starts on Wednesday. It's just going to make class go much, much quicker. So first off, what we need to do, and I'm going to send you the login information and the passwords in an email to you. Please, I stress this, please do not share this information with anybody. These training licenses for Nginity are just for this course and should not be used outside the course. First off, what you'll want to do is go to the Nginity website, and that address is given here. It's pretty easy to Google search, you'll find it. Once there, what you're going to want to do is go to the login page. So click on that, and that's right on the top. What we are interested in is this Nginity Pathway Analysis, or IPA for short. This is what we're going to use for next class period. And this is what you're going to download your gene list into to get a biological interpretation of your data. I highly recommend, I'm going to say this again, I highly recommend that you install the IPA client onto your computers. It makes downloading much, much quicker, and it's just kind of a better thing. If not, you can also use this login here, and this window, this will bring you to a window like this. Again, what you're going to do, don't use my email, but you're going to use the email, the training licenses, the email that I gave you, and we're all going to have the same password. Okay, again, please don't share this information with anybody. Once you have downloaded your client, it's going to be the same window, except that it's going to run much quicker and you're not going to have to update your Java. Okay, so after you log in, so put in your email, the password I gave you, you're going to come up to this window here. This is the IPA client. What's nice about it, it's very user-friendly. You can use the workflow to put your gene list in, or what I'm going to show you is just how to download it, and it's pretty easy. So over here on the IPA, what we're going to do is go to New. So we want a new project. You'll see some of my old projects here in some of my teaching classes. Don't worry about those. We don't need those. So hit New, and you're going to select this first choice, New Core Analysis. Okay, it'll bring you to this window. We want to upload a new data set. Okay, so you're going to have to find where you put those gene lists. Hopefully you remember. So I'm going to hit Upload. This takes me to that window where I've saved all my gene lists. I think for the first one, what I'm going to use is the one that was common to all our different comparisons. So remember, we looked at genes that were different at day 0, day 5, and then those genes that were different due to both day and cell type. Remember, we're doing pluripotent cells versus ES cells, or embryonic stem cells. So I believe this one had about 25 genes. Let's do that one first. That'll be easy. What I also want to say is it has to have a text at the end. So this other file is basically information for the Partech program. We don't want that. We just want the text file. So select the text file and say Open. Okay, I'm going to close this window. Basically, this is just a window. You have to tell the software what you're looking at. First off, this is our probe set ID. These are columns. This is basically the columns that Partech use. This software isn't going to recognize that. So we want to put this as our ID column, probe set ID. Okay, so we have 26 transcripts in here. It's not recognizing anything because we have to tell it what array it comes from. So when I go select identifier type, I'm going to put Affymetrix. And you can click off the entry gene identifier, hit OK. All right. Now what you see is that it started recognizing some of these. So some of these actually are uncharacterized transcripts, but some of them definitely are characterized. And so it's recognizing 22. So we have available 22 out of these 26 genes. Well, actually, it's 25 because we're not counting the header, that we can do biological analysis on. Okay? So now what I have to do is I got to select the p-value. What I'm going to do is I'm going to select the p-value for our day, for all those genes, the effect of day and cell type, both combined on our data set. So I'm going to put observation 1. You'll notice here it already knows it's a p-value. The software's pretty smart. So, but if for some reason it doesn't recognize it as a p-value, you can put whatever else you want in here. Okay, so we got p-value. Now what I want is fold change. And that information is kind of in the middle. If you go farther over, you'll see the fold change 5. What we want is fold change IPS cells, so the pluripotent cells versus ES cells. So all this fold change, so this gene right here is actually higher than the ES cells. So I'm going to put observation 1. And again, it recognizes that it's a fold change, exponential fold change. Okay, so we have our ID, our p-value, which is again the effect of day and cell type on the genes combined. And then the fold change, or the difference between the pluripotent cells versus the embryonic stem cells. Okay, I'm going to hit Save and Create Analysis. Okay, I'm going to choose a new project. So I'm going to make this IPS versus ES, and then differentiation state. And then just to remind me, I'm going to say that these are stem cells. Okay, hit Save. Alrighty. I'm going to leave the name just how it is. So ANOVA common, and it's all these different, the genes that are common between all our different comparisons. So I'm going to hit Save. Now here, basically what it's doing is it's asking us how you want to analyze this data set. This is a really cool page. One thing, I leave all the defaults the way it is. What I wanted to point out, though, is you can use different databases. They have a lot of different databases that you can use. You can also select, say you only want to look at certain genes that are known to be expressed in certain cell types. And this is a really nice function of IPA, is that if you're looking at, say, PBMCs or peripheral blood cells, there's all kinds of different types in there. You could specialize and say, I just want to look at those genes that are known to be in macrophages or immune cells or whatever you want. Again, just leave everything the way it is. So I'm going to select all. General settings, okay. And then this is just your range of your fold changes that you have in your list. Okay, so what I'm going to do is, everything seems to be good. I could also look at just things that are upregulated or downregulated, but we want to look at both. Then we only have 29 genes, and actually 19 of them have enough biological information that we can use this software to make connections if they exist between these genes. So I'm going to hit Run Analysis. Again, you could just save it under the same project and the same name. Hit OK. All right, so what you'll see is your list will show up in this menu bar here. And what'll happen, spinning wheel of death. What that'll do is, basically what we're doing is we sent our gene list to a supercomputer in, California, Silicon Valley. And basically what it's doing is it's using its database to tie all the biological information contained in that data set that's associated with our genes to our list and then send it back to us. So this does take a little while. But again, please do this for all your gene lists. And again, I would say for the fold changes, whatever your comparison is, if it's 0 to 5, use that fold change. Or use that p-value. I think maybe I think we should use all the same fold changes for all our gene lists. So be sure to select that column that gives a difference between IPS versus ES cells. All right, that's how you do it. I'll be in class tomorrow. Shoot me an email if you have any questions on this. Again, it's already done. Yeah, it's only 25 genes. But again, this is kind of what you get, is you get, the things that might be interacting in your gene list based on what we submitted. Okay? Yeah, that's really quick. Some of the pathways, and we're going to go over this in class. But what I want you to do is be able to download it. Make sure you download it. Migration of cells. Interesting. Be sure to download this before class. All right, thank you.